Okay, for what we have in number 14, we have y times y prime plus x is equal to the square root of x squared plus y squared. And if we isolate gradually the derivative term, so we will say we have y dy over dx is equal to the square root of x squared plus y squared, followed by the subtraction of x, and if I divide by y, so I have dy over dx is equal to the square root of x squared plus y squared over y minus x over y. And crossing over to what we have here, looks like we might have a homogeneous equation. So having v equal to y over x, and in effect having y is equal to v times x. So again, we have dy over dx is equal to the square root of x squared plus, and for y is equal to vx, if I square, we have v squared x squared you have over y minus x over y, and if you notice, okay, we have x squared common to x squared and v squared x squared, so I'm going to factor out the square root of x squared, or in effect just factor out x. We have over y, and we're going to have times the square root of 1 plus v squared and so for what we're going to have in effect, now considering that we have the reciprocal of v, so we have dy over dx is going to be equal to, and I can just go ahead and consolidate, saying that I have the square root of 1 plus v squared over v, and we have minus the reciprocal of v, so I can just say that I have the square root of 1 plus v squared followed by the subtraction of 1 all over v. And for what I have for y is equal to vx, so we're back in the terrain whereupon we have dy over dx is equal to v plus x dv over dx, and just setting the dy over dx terms equal to each other. So you're going to have v plus x dv over dx is equal to the square root of 1 plus v squared minus 1 over v, and looking at taking v away from both sides, and again subtracting v is going to be the same as subtracting v squared over v. And looking at separating the variables, okay, so we'll have v dv all over the square root of 1 plus v squared minus the quantity of 1 plus v squared is equal to dx over x. And if we look at integrating over both sides, okay, and for what we have on the left hand side, okay, so this is going to be a bit of a challenge. And looking at what we have here, so v dv all over the square root of 1 plus v squared minus the quantity of 1 plus v squared. And if I apply u substitution, and we'll say that we have that u is equal to the square root of 1 plus v squared. And if I square both sides, I will have u squared is equal to 1 plus v squared. And if I take the differential of both sides, so I will have 2u du is equal to 2v dv and putting dv in terms of du, so we have 2u du over 2v is equal to dv. So just looking at what we have in the integral, so we have in the denominator, so we got u in place of the square root of 1 plus v squared, and we have minus u squared. And again, I originally had v, and for dv I have 2u du over 2v. If notice we have 2's to cancel. Likewise, we will have v's to cancel. And so this will come down to where we have u over u minus u squared. So this would be 1 all over 1 minus u du. And being careful with what we have in the result. So if I have 1 over 1 plus u du, I would have the positive natural logarithm. But since I have a negative u term, I'm going to have the negative of the natural logarithm of 1 minus u followed by the constant. And looking at back substituting, okay, so we have the negative of the natural logarithm of the quantity of 1 minus the square root of 1 plus v squared followed by the constant. And putting back into place, so we have the negative of the natural logarithm of the quantity of 1 minus the square root of 1 plus v squared. Left hand side, okay, again we have the natural logarithm of x followed by the constant. And let's say that if I combine the natural logarithmic terms, okay, and so we'll say that we have, if I take like a negative of a constant, that's still going to be a constant. And if I take consolidating, okay, so you have a constant and addition between natural logarithmic terms. you'll be looking at multiplying the attachment. So we have the natural logarithm of x minus x times the square root of 1 plus v squared and in the follow-through, so have the natural logarithm of x minus x times the quantity, and remember we have that v is equal to y over x, so if I add 1 plus y squared over x squared, so we're going to land at the square root of x squared plus y squared all over x squared. And remember, square root of x squared is x, so these x's are going to cancel out. And so this will come down to the natural logarithm of x minus the square root of x squared plus y squared. And another way that I can express this, okay, is that if I take both sides as powers to which the natural logarithmic base e is going to be raised, we can just say that we have alpha is equal to x minus the square root of x squared plus y squared. And either answer is acceptable.